Picture a machine that could glide over open ocean, soft mud, ice, and solid ground without ever touching any of it. In the 1960s, engineers genuinely believed this single strange vehicle would soon replace ocean ships, passenger ferries. It rode on nothing but a cushion of pressurized air, hovering just above the surface like something from pure science fiction. Governments poured fortunes into it, airlines studied it closely, and entire cross-channel travel routes were redesigned around its strange way of moving. So why did this futuristic machine, once hailed loudly as the vehicle of tomorrow, quietly vanish from nearly every coastline? We're about to uncover the hidden engineering flaw that doomed the hovercraft long before fuel prices or competition ever entered the picture. To understand exactly what happened here, we need to travel back to the precise moment this strange idea was first born. In 1955, a British engineer was searching for a clever way to reduce drag on boat hulls. Water friction was the real enemy, slowing every vessel down and burning enormous amounts of fuel just to push through waves. Can you spot the clever leap he made that nobody else in traditional shipbuilding had ever seriously considered before that moment? Cockerell realized that if you trapped a thin layer of air beneath a craft, you could lift it clear of the water. His early experiments used something almost comically simple, just 2 tin cans, a hairdryer, and a set of kitchen scales. That crude setup created a ring-shaped curtain of air that held pressure underneath, lifting a small model just enough to float. This simple trick, later named the annular jet, quietly became the foundation of an entirely new kind of transportation altogether. But there was an immediate problem, because air alone could not hold a heavy, fully loaded craft steady in rough water. Can you guess what happened the very moment the open sea grew even slightly choppy beneath these fragile early prototypes? Waves punched straight through the thin cushion of air, causing the entire vehicle to slam violently against the surface below. The solution engineers eventually reached for was a flexible rubber skirt, hung loosely around the entire base of the craft. This clever skirt trapped air far more efficiently, letting hovercraft ride several feet above the water instead of mere inches. Suddenly, these machines could cross rough channels, climb straight onto sandy beaches, and even travel over marshland that swallowed ordinary vehicles whole. By the early 1960s, this one breakthrough in skirt technology finally made large-scale passenger hovercraft commercially, but floating on a skirt of air created a second problem almost nobody outside the design labs ever anticipated at the time. Can you guess what happens to noise and stability when powerful engines constantly force air downward through a flexible rubber curtain? The engines had to run at near maximum power constantly, simply to keep hundreds of tons of steel airborne above waves. This made hovercraft astonishingly loud, rattling windows on nearby shorelines and drawing constant noise complaints from residents living near every terminal. It also made them wildly sensitive to crosswinds, since a floating craft has almost nothing gripping firmly onto the water below it. A sudden gust could push a fully loaded hovercraft sideways across the water far more easily than any conventional ship or boat. Several minor collisions and beaching incidents over the decades made insurers increasingly nervous about covering these unusual. Engineers responded by adding skilled pilots, powered rudders, and reverse thrust propellers just to keep these machines pointed safely in one direction. The SR.N4, a massive cross-channel hovercraft roughly the size of a small aircraft, could carry 400 passengers. It crossed the busy English Channel in under 30 minutes, a small fraction of the time any conventional ferry could manage. Passengers genuinely loved the strange sensation of skimming across open water while barely feeling a single wave beneath their own seats. But here's the uncomfortable problem nobody during the excitement of that launch day truly wanted to talk about seriously enough. That flexible rubber skirt, the very invention that had made hovercraft possible in the first place, wore out shockingly fast. Constant contact with rough waves, coarse sand, jagged rocks, and harbor debris tore and abraded the tough material within just months. Placing an entire skirt assembly was staggeringly expensive, and larger commercial craft needed full replacement far more often than planned. Can you imagine running a busy airline where every single tire needed full replacement almost every single week without exception? That is essentially what hovercraft operators faced daily, and the mounting maintenance bills quietly began eating every dollar of profit. Meanwhile, the same powerful engines needed to lift a fully loaded craft clear of the water also burned fuel constantly. Hovercraft required roughly the same fuel demands as a small regional aircraft, just to travel a tiny fraction of that distance. When the 1973 global oil crisis hit, fuel prices worldwide quadrupled almost overnight, and operating costs became. Airlines and ferry companies alike quietly started asking whether this futuristic machine had ever really been economically viable at all. Then came the single biggest blow of all, one that had nothing to do with money or fuel prices whatsoever. In 1994, the Channel Tunnel finally opened for business, connecting Britain and France directly beneath the deep open ocean floor. Trains could now cross in complete comfort, entirely unaffected by weather, waves, or the punishing daily wear hovercraft always endured. So what actually killed the hovercraft in the end, after decades of genuine engineering brilliance and undeniable technological wonder along the way? It wasn't a single dramatic disaster or one catastrophic failure captured live on camera for the entire world to see. It was death by 1,000 tiny cuts, fragile skirts, thirsty engines, brutal maintenance costs, and very feature that made hovercraft feel magical, floating freely above almost any surface, also made them mechanically fragile and costly. Engineers had built a machine that could technically travel almost anywhere on Earth, yet economically it could barely survive its own success. Today, only a small handful of hovercraft services still operate anywhere in the world, mostly for military use or short island crossings. Some guards still rely heavily on them precisely because they can rescue stranded people across ice, mud, and open water alike. The last commercial channel hovercraft made its final passenger crossing back in the year 2000, quietly closing an entire chapter. Aviation historians still call the SRN-4 one of the boldest and strangest commercial gambles of the entire 20th century ever attempted. Modern engineers still study Cockerell's original air cushion principle closely, now applied widely to warships. The hovercraft never truly failed as a brilliant idea, it simply arrived inside a world unwilling to pay its steep price. Sometimes the cleverest engineering solution in an entire field isn't the one that wins, it's the one the market sustains. And that quiet lesson, buried inside worn rubber skirts and thirsty engines, still shapes how engineers design new machines today. Thank you very much for watching, and I'll see you in the next video.